Hi, we meet again. So right now we are going to look at another questions on paper 3. Now a group of students carry out an experiment to study the effect of enzyme concentration on the activity of salivary amylase. Now we learned about the enzymes in chapter form 4 chapter 4. So diagram 1.1 shows the method used by the students set the time at 1 minute intervals to transfer a drop of mixture from test tube C to the groove tile until the yellow color of the iodine solution remain unchanged. So the time taken for the hydrolysis of 1% starch to be completed is shown in the table. Now let's look at this diagram first. Now basically you need to maintain the temperature of two solutions here. One is the starch solution and the other one is the amylase solution. And of course when A and B are mixed in C, then the amylase is going to speed up the hydrolysis of starch into maltose. So once they are mixed, then you are going to start the stopwatch, and immediately a drop of the mixture will be taken out using the dropper for iodine test. Now, so if starch is present, then the iodine solution is going to change to blue-black. How do you know that the starch has been completely hydrolyzed by the amylase? It is when the iodine solution remains yellow. All right. So let's continue reading. Now the whole experiment in diagram 1 was carried out using different concentration of the salivary amylase, which is 0.5, 1, and 1.5%. So this would be our MV. And then the time taken definitely must be the time taken for the complete hydrolysis of starch will be the one that we measure. It is the ORV. Now, so how do you, now let's say if you are not able to find out the MV, RV, and ORV, then you need to refer to questions number E1. Now, in questions number E1, you will be asked to construct a table that includes the following aspect. So percentage concentration of salivary amylase. So this is our MV. Then the time taken for the starch to be completely hydrolyzed will be our ORV. This is what we measure, and from what we measure, then we calculate the rate of enzymatic reaction. This is the RV. So this is the first method to get the MV, ORV, and RV. Now, of course, you can also refer to the table. On the far left, we have the MV, the concentration of the salivary amylase, and the time taken is the ORV. All right. So this is the second method to get the MV and ORV. Then what is RV? And there's actually another method to find out. It is from the question itself. So you have the effect of concentration. This is the MV, and the activity of salivary amylase. This is your RV. So to cut it short, if you can't find them, please refer to questions E number 1. You'll be able to find the MV, ORV, and RV. Now let's look at the first question. Now based on table 1.1, state 2 observation on the relationship between the quantity of salivary amylase and the time. So if you still remember, it is very important to state the MV and the ORV. So before we can answer this, then we need to complete the diagram, the table first. So when the concentration of the salivary amylase is 0.5%, so what is the time taken? Now this is normally the first data will be given to you. So it is 19 minutes. So that means to say that at 19 minutes, the iodine remains yellow. So which means to say that the first group corresponds to t equals to 0. Then this is t equals to 1, 2, 3, 4. Then we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. At t equals to 18, the iodine is still blue-black. So it is at 19 minutes that the iodine remains yellow, which means to say that the starch has been completely hydrolyzed at this time. Okay, then let's find out what is the total time taken when the salivary amylase concentration is 1%. So it is t equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on the 11th minute, the starch has been completely hydrolyzed, and this is t equals to 0, 1, 2, 3, 4, 5, and 6. In 6 minutes, starch has been completely hydrolyzed. Now we are going to state the MV and the ORV. Now, as simple as that. So the percentage concentration of salivary amylase is when the percentage concentration of salivary amylase is 0.5%, the time taken for the starch to be complete hydrolyzed is 19.0 minutes. Now where do I get all this wording or all these phrases? Now basically I just copy and paste from questions number E1. Then for observation number 2, I'm going to choose another observation with the lowest ORV. So when the percentage concentration of the salivary amylase is 1.5%, then the time taken for the starch to be completely hydrolyzed is 6.0 minutes. So immediately you get 3 marks. Then number 2, state the inference which correspond to the observation. So remember, this is a template. First of all, I have to mention the ORV. This is what I get from E1. Then I need to relate it to the MV, and finally I make a conclusion about the RV. So the time taken for the starch to be hydrolyzed completely is longer, because it's 90 minutes, and our first observation is 90 minutes. It's longer. Why? Because I need to relate it to the MV, because the concentration of the salivary amylase is low. So let's continue elaborating. There is less amylase to bind with the starch, or there is less amylase to speed up the hydrolysis of starch. So that's why, or as a result, the rate of enzyme reaction is low. Okay, so you get 3 ticks for this 3 criteria. And then inference number 2, we are going to talk about observation number 2. Now, like the previous one, the time taken for the starch to be hydrolyzed completely is shorter, because it's 6 minutes. Then let's relate it to the MV, because the concentration of the amylase is low, so that's why there is less amylase to bind with the starch. So that's why the enzymatic reaction is low. It is high. This time it's high, so that's why the rate of enzymatic reaction is high. So remember, when you are writing an inference, make sure that you state the ORV followed by MV and lastly your RV. Now next one is B, complete the table 1.1. So we have completed it just now. So it's 19, 11, and 6. And C1, complete the table 1.2 based on this experiment. So we have MV, RV, and CV. Now MV, I got it from E1. ORV also from E1. RV, the rate of enzyme reaction, also from E1. Then we are going to construct a sentence using this phrase. Use different percentage concentration of salivary amylase, such as 0.5%, 1%, 1.5%. Alright, so state it out. So it's 0.5%, 1.0%, and 1.5%. So immediately, you get 2 ticks. And then let's say I choose to write the ORV as my responding variable. So what is my behavior? My behavior is measure and record the time taken for the starch to be completely hydrolyzed using stopwatch. Time is measured using stopwatch. If I choose to write RV here, then my behavior is calculate and record the rate of enzyme reaction using formula. Now, if you do not know the formula, then you should look at E1. Let me show you E1. Now in SPM, you will be given a formula. So make use of the information in E1. Okay, so by doing so, you get 2 ticks. Alright, now next one. Okay, now of course some of you will ask, okay, do I need to write both? No, you just need to choose one. You either write the ORV or RV, either one. If you choose to write ORV, then your behavior is measured. If you choose to write RV, your behavior is calculated. Now next one is control variable. Now where to find the control variable? Now you need to refer to the questions. Try to find anything with figures. Now for example here, that water bath is maintained at 37 degrees Celsius. I find a figure here. I also find figures here. Volume of starch solution, volume of amylase solution. So all this will be my constant variable. So it can be the temperature of water bath. So I'm going to use this phrase to construct my sentence. Fix the temperature of the water bath at 37 degrees Celsius. Just copy and paste and build a sentence of this phrase. Okay, as simple as that. Okay, immediately I get another 3 marks. Now next one is D. State the hypothesis for this experiment. Since the MV, the percentage concentration of the salivary amylase, can be measured, so I'm going to use the first template. As the percentage concentration of salivary amylase increases, the time taken for the starch to be hydrolyzed completely decreases. Okay, done. Straight away you get 3 marks. Or you can write this way. As the percentage concentration of salivary amylase increases, then the rate of enzymatic reaction increases. Now, both also give you 3 marks. Then E1, construct a table. Make sure that your table has all this aspect. So I have a frame for my table, and then I just copy and paste from E1. Percentage concentration, copy and paste it here. The time taken for the starch to be hydrolyzed, complete, copy and paste. And lastly is the rate of enzyme reaction, copy and paste. Make sure that I have units for all of them. So this will give you the first mark, title with the unit, and then next one, the next mark comes from the transfer of data, transfer it from questions B just now. And finally, I just calculate based on the formula given. Is 1 over time. Now please note that the unit for rate of enzyme reaction is per minute, not 1 over time. 1 over time is the formula. Unit is per minute. Okay, now next one is E2. On the graph paper, draw the graph of Y against X. So the rate of reaction of salivary amylase is the y-axis. Concentration of salivary amylase is the x-axis. Don't mix them up. So this is what we are going to construct. Now, so first of all, I label my axis. This is my y-axis, my RV with the unit, MV with the unit, and then make sure that I have the scale, the uniform scale, and then I have transferred my data correctly with smooth curve. Don't join the line, don't join the dots or the crosses with ruler. Make sure that it is a smooth curve. Do not extrapolate, just start and end with what you have. Alright, so first of all is title plus unit plus scale, it gives it 1 mark, and then you have data transfer, another mark, and finally you have a smooth curve, so you have 3 marks from E number 2. Now is F. Explain the relationship between the rate of reaction of salivary amylase, so this is our RV just now, and the concentration of the salivary amylase, our MV. So the first sentence is like writing a hypothesis. As the percentage concentration of salivary amylase increases, the rate of enzymatic reaction increases. Then I need to explain about this relationship. Because as I increase the concentration of the salivary amylase, actually there are more amylase to bind with the starch, or I can say that more starch will be hydrolyzed to maltose, and as a result, the time taken for complete hydrolysis of starch is shorter. Now, as in inference, make sure that you have the MV, RV, and ORV in your explanation. G. Based on this experiment, what can you deduce about the rate? The rate is how fast the activity of salivary amylase. So if you say how fast, it is always per unit time. So what's the template? Make sure that first of all you define it operationally. Okay, suit your definition based on this experiment, followed by the second sentence, which is shown by the ORV, and finally is affected by the MV, which is the percentage concentration of salivary amylase. Okay, I'm sure you can write the second and the third sentence, but let's see how to write a complete operational definition. A rate of enzyme reaction in this case is the hydrolysis of starch to maltose. we use the starch here as our substrate in the presence of water, because the process is hydrolysis. Definitely we need water, and this process is actually sped up by the amylase, the salivary amylase, and this is a rate, so I have to include this phrase here, a per unit time. So this is a hydrolysis of starch to maltose in the presence of water, which is sped up by amylase per unit time, which is shown by the time taken ... and is affected by the percentage concentration of the salivary amylase. This is how you get 3 marks for operational definition. Now, H, the experiment is repeated using the same apparatus and material, but the quantities of the salivary amylase used is 1.5, and the temperature used is 20 degrees Celsius. Now, if you look at the table just now, when the percentage concentration of salivary amylase is 1.5%, the temperature was actually kept at 37 degrees Celsius. Right now, you repeat the same experiment at a lower temperature, which is 20 degrees Celsius. So we were to predict the time taken, predict the ORV, and explain your prediction. Alright, so first of all, I need to predict the time taken. So let's use 1.5%, 37 degrees Celsius as my benchmark here. So it was 6 minutes. So if I reduce the temperature, then the time taken will be longer, since the rate of reaction is lower. So the time taken for the starch to be completely hydrolyzed is more than 6 minutes. So I get one for this. Now, of course, I can't say the percentage concentration. I shouldn't relate it to the percentage concentration anymore, because my MV right now is 20 degrees Celsius. Okay, we have 37 degrees Celsius and 20 degrees Celsius. So I have to relate it to the temperature, because the temperature is low. When the temperature is low, the enzymes are not active. So lastly, the rate of enzyme reaction is low. So again, you see ORV, MV, and RV in your explanation. Lastly is I. So we are to classify the items into material and apparatus. So material, most of the time they are disposable, and apparatus we reuse them again and again. So thermometer, stopwatch, cavity tile are apparatus, and then starch solution, iodine solution, and salivary amylase are the material. So you get 3 marks. Alright, so hopefully it gives you some insights about how to answer paper 3 questions number 1. So if you look at it, in almost in every questions I have the MV, RV, and ORV. So good luck. Thank you.